Alright, this next section we're going to talk about polygons. And our first definition up at the top is a polygon is formed by 3 or more coplanar segments. And remember that word coplanar means in the same plane. So our 3 coplanar segments called sides that intersect only at their endpoints. That is our definition of a polygon. And the intersection of 2 sides we call a vertex. So we've been using all these terms so far in our triangles. In this example down here, you can see the points where our sides come together. Each one of these points is a vertex, and all of our sides in this polygon are in the same plane. They're all laying on this piece of paper, so this is our first polygon. So I'm going to name each vertex so that we can do a few things with our polygon. So this is vertex A, B, C, D, and E. So the first thing we're going to do, if we want to name this polygon, the way we do that is with our sides, and we are going to call it polygon A, B, C, D, E. Pretty simple. We don't have to put any lines above or anything since we have this word polygon out front. We know that all these points are talking about our polygon. Then we are going to label our sides. And we have got 5 different sides on this polygon. So we are going to say we have side AB, and now I'm going to put the line over the top because that's a segment, AB, BC, CD, DE, and EA. Those are my 5 sides of the polygon. And then finally I'm going to list the vertices. And those are all my points. So I have vertices A, B, C, D, and E. Okay, so then I'm going to scroll down a little bit and we're going to move to our next set of definitions. So our polygon can be either convex or concave, and we're going to talk about what those both mean. Convex or concave. And the way we determine if our polygon is convex or concave, we do this test down here, and our test is to extend the sides to see if they pass through the interior of our polygon. So if we look at this first polygon drawn here for us, if we extend all of our sides, we can see that none of those sides are going to come together inside of our polygon. So that makes this one convex. If we look at a concave polygon, I'm going to draw one here quick. If we have a polygon like this, I have all my sides are in the same plane, connected at the vertices. If I were to extend all the sides on this polygon, extend it out here and here. So far they aren't going inside my polygon, but now when I get to this point, extend this side and this side, they are passing through the interior of my polygon, so that makes this shape concave. This next page is looking at classifying polygons by their number of sides, and you should be familiar with at least these first couple. So our triangle, we have 3 sides, and I sketched it out there. You can draw in your sketches on the side as well. Quadrilateral has 4 sides, pentagon has 5, hexagon 6, etc. So those are some good ones to know, and you can fill in the rest of those drawings for your polygons. Then when we have a polygon whose sides are congruent, that is called a regular polygon. So if I were to draw a regular quadrilateral, otherwise known as a square, all 4 of my sides would be congruent, and I can label that like this. That tells me all 4 sides are congruent. That is my regular quadrilateral, or a square. So then the next example asks us to name the following for polygon A, B, C, D, E. This is our polygon on the right here, and it asks us to name the 5 vertices. We are going to name the 5 points on our polygon, which are A, B, C, D, and E. Then to name our 5 sides, we name the 5 segments that make up that polygon, which are A, B, BC, CD, DE, and EA. It then asks for all angles that are consecutive to angle A. Consecutive means that the angle or the vertices share the endpoint of the same side. So that means if we're looking at angle A, we're looking for vertices that share A as our endpoint, or sides that share that endpoint. So we have this side with this vertex that shares the endpoint, and this side and that vertex shares that same side. So our consecutive angles to A are angle E and B. Then it asks for all sides adjacent to ED. Adjacent means next to. So if we have ED right here, we're looking for all sides adjacent to ED, which gives us DC and EA. EA and DC. E, adjacent, again means next to. I'm just going to draw that line up here. Adjacent means next to. So all of the vertices adjacent to point D here would be E and C. When we name a point, we don't have to label anything. We can just list our 2 letters because our capital letters mean points. And then F asks for all diagonals with endpoint D. So a diagonal in our polygon is a line that goes from a vertex that is not adjacent. So I'll write that down. Diagonal. It's a line to our point from a vertex not adjacent. So in this example, we are looking at point D, and we want to draw a line from vertices not adjacent. So that would mean not E or C. So we have a line from AD and a line from DB. Those are our 2 diagonals with endpoint D. So we can list those out. We have line AD and line DB.